Okay, so 4-2, we're going to be focused on two different of the problems that you've been doing. This one is going to be the perpendicular bisector, and then the angle bisector. All right, so let's just call this one, the section, perpendicular and angle bisectors. Now you guys know how to name them in a picture or in a drawing, but you now need to know how to be able to solve for a missing part. So first of all, quick review. If a point is on the perpendicular bisector of a segment, then you're going to know that it's equidistant from the end points. Okay, a perpendicular bisector has to be perpendicular, and it has to cut the segment in half. But notice here, when you have that perpendicular, or you have this segment right here, and it's bisected at a right angle, what they're saying is that any point along this line, along that bisector, will be the same distance to this side as it is to this side. Essentially, you're creating two congruent triangles right there. So, this part is easier than yesterday. It's just a matter of identifying which equation you can make. And obviously, the converse means that we go backwards. If you find a point that is equidistant from the endpoints of a segment, then you're going to know that that segment here is perpendicular to the segment and it cuts it in half. So there's two things. If you know that they are perpendicular and bisects in half, then you know that those two sides will be the same. If you know that these two sides are the same, then you know it has to cut it in half at a right angle. So number one, what are you given? What markings? What do you know? It's perpendicular and it's also what? Congruent. So it is a perpendicular bisector. You have to know that before you can use the rule. So it's a perpendicular bisector. So because of that, what are you allowed to say? What two things are equal now? The 8 and the... Those two things are equal. Because it's on a perpendicular bisector, any point here would be equidistant from here to here and from here to here. It's the same distance. Now don't write this down, but think about it. What if I drew a segment right here, and that's the middle, but I drew a segment like this that's not perpendicular? Is that the same distance to here as it is to here? No. That's why it has to be on a perpendicular bisector, so it could be the same distance from both sides. All right, number two, what do you know for a fact? What's given to you? We're given a right angle, good. But we're not told that's cut in half. What are we told? That those two things are equal, right? You already know that this point N is equidistant, same distance to L as it is to M. That means it's on the perpendicular bisector. If those two distances were equal, like up here and here, then it wouldn't be the perpendicular bisector. So if 5 equals 5, then you're allowed to say, let's see, N, write this down just so that you have this to refer back to. We know that N is equidistant to L and M. In other words, we know that the distance from N to L is the same as the distance from N to M. So because of that, we're allowed to say that what equals what? Okay. Yep, Ln and Nm is equal. That was the given part. Now what's the conclusion part? We know that that makes this a perpendicular bisector. That's right. Good job. LP equals PM. So therefore 2x equals 4, making x equal to 2. That's it. So you're going to look for the right equation, and when you're doing your homework, you probably will just see all this and write down the equation, but I'm trying to make sure you understand when you can use it. Number 3, what do you know for a fact? It's perpendicular and the two halves are congruent, so we know it's a perpendicular bisector. TU is a perpendicular bisector. The upside down T means perpendicular. We know that. That was given. So what are we allowed to say then? The point T now is equidistant to both endpoints. That's right. RT and TS are congruent, meaning 10x minus 3 has to equal 5x plus 2. That's right. Once you know one of the parts is true, then you can use the conclusion. So that would make minus 5x would be 5x plus 3 would be 5, and x would equal 1. You know what I didn't do? I didn't go back and read the directions. Let me make sure that I finished the question. Did it only say find the value of x? Okay, then I'm good. All right, number 4, think about what you know. Do you know it's a perpendicular bisector, or do you know that there's a point on that line that is equidistant to the two endpoints? Yep. QR and PQ are the same. That means Q is equidistant to the two different endpoints. Therefore, so Q is equidistant. I'm just going to say from the endpoints. So, since Q is equidistant from the endpoints, I know it has to be a perpendicular bisector. So they've got the perpendicular part. What can I say? What else can I say here? Yep. It has to be a perpendicular bisector. There's the perpendicular, there's the bisected part. So 12 minus x is equal to 2x. It's going to be one or the other. Either the two sides are going to be equal, or the two, I don't want, how do you say hypotenuse plural? Both of the hypotenuses are equal to each other. So if you add x to both sides, 12 equals 3x, and you got 4 also? Okay. Okay, so that's one of the rules that you're going to be using today. The other one is very similar. It's just the picture is going to look different, but you're going to find one thing that's true, and you're going to make an equation from it. So, angle bisector. If a point is on the bisector of an angle, if it's on a segment that's going right up the middle, then that point is equidistant from the sides of the angle. Which makes sense. If you hadn't, don't draw this, but if you had an angle like this, and I had a segment that was not on the bisector, if I drew one that was off to the side, this distance is not the same as this distance. It would have to be on the bisector. It had to be going right up the middle in order to be the same distance. All right, so the converse, if a point is on the angle bisector, or I'm sorry, if a point is equidistant from the sides, then you know it's an angle bisector. So if you already know that the distances are the same, then you're allowed to say, hey, the angle is cut in half. All right, so number 4, what do you know? Do you know that the angles are bisected, or do you know that there's a point that's equidistant to the two sides? What's given to you in the markings there? There's a point that's the same distance. Good. And 70 is one of the angles. That's good. But what we're given right here is that this side is equal to this side, meaning that this point here is the same distance to this side as it is to this side. And distance is always measured by the right angle. So we know that the point is equidistant to the sides. Write that down in your notes just so you can look back at it. You don't have to write that for your homework. You can just make the equation. Because that point is equidistant to the two sides, what does that mean? So we have a what? We know that 70 equals x, right? What we have then is a bisector. We know then that that has to be cut equally in half. So x would equal 70. You have to know one or the other before you can use the equation. Number 5, what do we know? Okay, they have right angles. That indicates distance because you always measure it straight on. And what else do we know? Yep, we know it's an angle bisector because 38 equals 38. We're told that. We know it's an angle bisector because the angle is cut equally in half, 38 and 38. So we know that any point along this angle bisector has to be the same distance to here as it is to there. So what equation can we make? And x equals 4. Okay, so you might be looking at this and saying, well, okay, it's obvious. I can just make those two things equal to each other. But on your homework or on your classwork, there's some that say, can you use this rule or not? You have to know what the criteria is. All right, and number 6, what do you know? They're the same distance to the edges. Good, we know that much. The point is equidistant, same distance. So therefore, we're allowed to say that makes it a bisector. So it's a bisector. So what has to be equal to what? Good. We know that this has to equal this. If the angles are bisected, then these distances will be the same. Has to be at a right angle though, otherwise it's not the true distance. So subtract 2x from both sides, divide by 2, you get x equals 10. Okay, any questions on how that works? All right, so then the hard part is just going to be making sure that you answer the question the way it's asked and everything. Turn the page. Let's do a couple of these. They're kind of short. I mean, I know they look long, but that's because there's a lot of space there. So looking at this picture, what do you know? Do you know that these sides are equal to that by your given information? That's what you're going to conclude. What do you know for a fact? What are you given or told? Good. So it's perpendicular. Is it also a bisector? Yep. This is perpendicular, that's right, and this is bisected, that's right. So therefore, you're allowed to say that this point is the same distance to here as it is to here. So to find x, you would say 4x equals 3x plus 4. Subtract 3x from both sides. X equals 4. Go ahead and find A, B, and B, C. Bless you. So what'd you get for number 2 and number 3? Both are 16. Good. You plug them in. All right, number 4. Look at this example right here. MO. This segment is the perpendicular bisector of what segment? What segment got cut in half? What is MO going right down the middle of? Which segment? PN or NP? Yep, however you want to say it. So it's the bisector of PN. Goes right up the middle. Because of that, we know that everything is either bisected going that direction or that it's equidistant to the endpoint. So if MP, or find MP right here, what would that have to be then? 4.5, good. Because M is on the perpendicular bisector. Can you find NO? 9.5, good, because O is on the perpendicular bisector going that way. 9.5. And NP, what would NP be? 6.4. Excellent. 3.2 and 3.2. Go ahead and try number 8 on your own. When it says how far is M from KL, it means what is this distance right here? And obviously that one's already given to you. But go ahead and answer 8 through 13. Okay, so the distance to KL would be 8. That was given. How far does M have to be then from JK going over to this segment? 8. From M over to JK. How is KM, how is this segment right here related to the angle? What is it? Angle bisector. Good, because the 8 and the 8 are the same distances. Since it's an angle bisector, that means that this angle equals that angle. So you're allowed to say that 3x equals 54. 3x. Thank you. I was thinking 28, but that didn't quite work. X equals 18. Did you find the measure of angle MKL? Right here? Already given, 54. Good. Find the measure of angle JMK and LMK. So they didn't ask us for JKM, but we would know that that's 54 as well. They want the measure of angle JMK up here. They want to know what this angle is and what this angle is. Any ideas on how to figure that out? Add them and then what? Adding is right? No, close. You add them together and then you subtract from 180. That's right. This entire triangle is 180. So it's 180 minus the 90 we already have right here, minus the 54. And what did you get? 6. 14. Is that 3? Is that right? All right, 36 degrees. Okay, so you will need to know things from the past as well. All right, so I'm not going to help you, or I'm not going to do the last, ooh, can I undo whatever just happened there? I want you to look at number 14 on your own. Find AB if AD is a perpendicular bisector. So it tells you that AD is a perpendicular bisector. It gave you that fact. So you had to figure out what AB would be equal to. Before you go on, what fact did you use? What equation did you make? Good. Since it's a perpendicular bisector, that point A is the same distance to this endpoint as it is to that endpoint. So 3x minus 2 equals x plus 10. Go ahead and solve it and answer the final question. It's not asking for x. Did you get x equals 6? Yeah. And then AB would end up equaling 16. All right, now number 15 is one of those problems where you can't just start making things equal. There's too much information there. And not both of those things are equal. You're going to have to figure out which one is actually true. You were told that AD is an angle bisector, meaning that this angle is cut in half. Because of that, which two segments are equal? DC? That's good. That's what makes this one confusing. So when you look back up at the rule, it's the side that's across from the angles that are equal to each other. Okay, when these two angles are cut in half, it goes across from them like that. It's the one that starts at that point that's on the bisector and goes to the sides. So when you look at the bottom one again, which two segments start at the point that's on the bisector? It would be this segment is equal to that segment, okay? The rule doesn't say that anything about these two segments right here. It only talks about the angle, or I'm sorry, the segments that are inside the angle bisector. So you would make the 4x minus 5 equal to 3x plus minus 1. Be careful about that. If they give you too much information, it's because they want to test that you can find the right angles. So x equals 4 and AC equals 4 times 4 minus 5. 16 minus 5, 11. Okay, so I just want to verbally quiz you on a few. We don't really have time for you to do this in your computers because I want to give you time to work. But is anyone still writing? I want you to tell me what you can conclude, just out loud. Okay, so don't go into it. Let's just look at it. What could you conclude from this one? What equals what? That one would have to equal that one. So 2x would have to equal 4. X would equal 2. Why? Because these two were already equal to each other. What about this one? Oh, sorry. I asked the questions different ways. What do you know for a fact here? Those are equidistant. Good. So what can you conclude? That the angles are the same. Good. 4x would have to equal 2x plus 20. All right. What do you know here for a fact? All right, and that's on the segment. It's also perpendicular. That segment is being cut in half. So what are you allowed to conclude? That those two are equal to each other from the point H. So 2x minus 3 equals x plus 2. Hold on a second. I want to get to the last one. Okay, what do you know here for a fact? Okay, so we know that RS is bisected. Do we know anything more than that? No, it's not a perpendicular bisector, so we can't conclude anything. Your answer would be no solution or no conclusion. Okay. All right, so go ahead. As much as possible, I'd like you guys to be able to get this done in class. Hold on, let me refresh because I've changed that.